Alright, so here we are with part 2. If you haven't done this already, I want you to pause the video and try this one on your own. Unpause when you are ready to check. Alright, so here this might have seemed a little easy at first, but then actually it's a little bit tricky. Hopefully you got it though. So our answer, the surface area is increasing at 8/5 inches squared per minute. Okay, great. How do we come up with that? Well, we're given the volume, or I'm sorry, the rate of change of the volume. So we know that that's dV dt, 2 inches cubed per minute. We know that we care about this when the length of one side is 5 inches. So that's a variable, it's not a constant. So since we know dV dt, we need to use the volume and dV dt, the rate of change of the volume, in order to find the rate of change of one of the sides in order to find the rate of change of the surface area. So in this case, we're going to use a volume equation. Volume equals x cubed. Check out that cube. We know x is 5 at the instance we care about. We know dV dt is 2 inches cubed per minute, but we have to find dx dt in order to find dSA dt, where dSA dt is the rate of change of the surface area. So I also know my surface area equation is 6x squared, because there are 6 sides to a square. Each has an area of x squared. Great. Alright, so the first thing I do is the derivative of the volume with respect to time. So dV dt equals 3x squared dx dt. Plug in dV dt, plug in x, solve for dx dt. So dx dt is 2/75 inches per minute. Good. Now I come over to my surface area equation, and I take the derivative of that with respect to time. So dSA dt equals 12x dx dt. Plug in all the knowns, 12, 5, 2/75, and I get 8/5 inches squared per minute. So the surface area is increasing at 8/5 inches squared per minute. Okay, so we want to understand not only are related rates incredibly fun and awesome because they're an actual application. Like, think about, what does it mean? You are relating rates. Rates are things changing with respect to time, and you are finding relationships between them. So hopefully, whether this is something you're doing on a daily basis or not, you can at least see how this is incredibly applicable, because things are moving all the time, and it's helpful to understand how they move with respect to each other. Yeah, applications of math. Mind blown. Okay, but in terms of actually doing related rates problems, it's really just using a lot of chain rule and implicit differentiation. Don't forget, you might have to do the product rule here or there, but actually a lot of times you need to get it in terms of just one variable, so that'll eliminate using the product rule. Sometimes it won't. And then again, I want to emphasize, make sure to perform step 3 from the guidelines before step 4, and step 4 is where we substitute in all the values. So we don't want to substitute in anything unless it's a constant until after the derivative. That's crucially important. Otherwise, you're just going to be taking a bunch of derivatives of constants, which are 0.